intersection. Now we are moving on to another important aspect, and we will continue with the conditions later on, but this is something which is mentioned in the conditions themselves. Okay, so there you can see there the condition of sight distance. So sight distance at the intersection is a very important uh, issue, and especially the intersections which don't have a signal, because eventually you will enter the intersection on the basis of your judgment that how far is the other vehicle, and for that you need enough sight distance. Another unique aspect of sight distance on the intersection is you are not looking at the road in front of you, you are looking at the road at your side. So even if the road in front of me is clear up to many kilometers, but I cannot see the vehicle coming from the side road, from the crossing road, then the sight distance is not enough for me. Okay, so on the intersections you have to worry about the sight distance which the driver has to see the road across. So in this diagram you can see that there are two cars coming from two different roads, and they have obstruction on the side of the road, and the obstruction limits the sight distance from which you can see the other car. So from here I can see this car when the obstruction is here. If I move the obstruction closer, this will block my line of sight. Okay, so if I move the obstruction here, then my line of sight is blocked. So from here I can only see up to this much. Okay, so this is the importance of the obstruction on the side of the road when you are judging the sight distance for the intersection. Now here in this diagram there are four important distances. The first one is before we go into the distances, there is a crossing point. Okay, so if both vehicles came to the intersection at the same time, they will cross each other at point B. So B is the conflict point, the location of the conflict point. Okay, so the distance from the location of the conflict point, from where you can start seeing the other vehicle, that distance is called dA. Okay, so distance from the conflict point at which you can see the other vehicle, that is called dA for one vehicle. For the other vehicle it is dB. Okay, so there is road A and there is road B. The distance along road A from which you start seeing the other vehicle is dA, and this distance from the conflict point to the position from where you start seeing the other vehicle. Okay, and for the other vehicle the same distance is called dB. Okay, so distance is measured from the conflict point to the point from where you can look at the other vehicle. So one is called dA, the other one is called dB. The other two distances are the distance from the center line of the lane to the obstruction. The center line of the lane to the obstruction. Which lane? Your road may have multiple lanes. So the lane in your direction which is closest to the obstruction. Okay, so you can see for road B, I am taking the distance from here to this lane, because I am talking about this direction. So the closest lane in this direction to the roadside obstruction is this one. Okay, so B is from the obstruction to the central line of this lane. If I go to road A, then I am talking about this direction, not this one. Okay, I am not talking about this direction, I am talking about this one. So I will take the distance to the center line of the lane closest in this direction. Okay, so the distance to the closest lane in A is A, and the distance to the closest lane in road B is small b. Okay, so DA and DB are distances to the conflict point, and A and B are distances to the closest lane. Okay, now if you look at, let me remove the extra lines here. Okay, so if you look at the position of this car and point B, it makes a triangle. Okay, it is making a triangle. In this triangle, this distance is dA, this distance is dB. Okay, so if I take the ratio, it will be dB upon dA, perpendicular upon base, dB upon dA. Okay, and if you look at the road obstruction and this car, it makes another triangle. Okay, it makes a smaller triangle. Okay, which is part of the bigger triangle. So this one is a smaller triangle. For this small triangle, the perpendicular is A and the base is dA minus B. Okay, what was dA? The full distance, and B is from here to the obstruction. Okay, so this one remaining is dA minus B. So A upon dA minus B. So these are two similar triangles. One is this bigger one between the two cars. The other one is smaller one between the obstruction and the car. Okay, so for this one, dB upon dA. For the small one, A upon dA minus B. So we have these two triangles over here. Now, this equation gives you the relationship between the obstruction distance from the road and the distance which is available to the conflict point. So if the obstruction distance is A and B, the distance to the conflict point is equal to dA and dB. Now, if I see the car is coming from the other direction, okay, and I feel that it is too fast and too close to me, then I may decide to stop, right? If I decide to stop, I should be able to stop before I reach the conflict point. So if the driver at point A looks at the other side and he sees another car which is coming too fast, and this driver thinks I should stop, okay, then his stop should be before point B. Okay, so when he looks at the other car and he decides not to move, or he decides to stop, the distance between point A and point B should be enough for him to stop. Okay, in the other words, this distance should be at least equal to his stopping side distance. You have seen this equation in the traffic course as well as in the highway course. If you haven't taken the traffic course, you have seen the same equation in the highway course. Okay, so, and the same thing for the other driver as well. If this driver is coming and if he wants to stop, still he has to stop before reaching point B. Okay, so the distance between point C and point B should also be equal to the required stopping side distance. So in this triangle, these two distances should be equal to the required stopping distances for each car. Okay, will they be different? Yes, depending upon the speed and the gradient. Okay, maybe this road has one gradient, this road has another gradient. This car is coming at 50 miles per hour, this car is coming at 60 miles per hour. So both of them may require a different side distance. But whatever the side distance they require, it is equal to the distance, or it should be equal to the distance which is available to the conflict point. They have to stop before the conflict point. Okay, so whatever is the distance d and db, it should be at least equal to the distance they need to stop. Okay, so you have the equation which joins A, B and the available distances to the conflict point, and you know these distances should be equal to the, at least equal to the stopping side distance. So the speed is taken as the 85th percentile for each road, whichever road you are calculating the distance for, and the normal reaction time t value is taken as 2.5 seconds. Okay, so t is your reaction time and s is the speed of the route, and normally which is taken as the 85th percentile speed. Okay, 85th percentile meaning the 85th highest speed on the road. Okay, so if you take 85th percentile, that means I'm covering the speed of 85% of the drivers. 85% of drivers are driving at this speed or less. And then G is a gradient, as I told you. Okay, so this is one way of uh, connecting the available distance on the road to the conflict point with the distance on the roadside obstruction, and how it is connected with the side distance. Do you have any questions? Is it clear? Yes, is this explanation clear? Okay. So this is one way, so I can put the side distance into these equations and I can know how much should be the roadside obstruction. Or I can fix one of them and I can put the other as side distance, and I can know the other distance, available distance, and so on and so forth. Okay, so out of these four distances you can insert three and you can pick the fourth one, and you can check if that distance is equal to the required side distance or not. Okay, so if I calculate dB from this equation, it should be equal to the required side distance. If I calculate dA from this equation, it should be equal to, in the end, to the required side distance. Okay, so this equation gives you the actual distances, and then you can check it with your required distance, whether dA or dB, depends upon you. Then we have an empirical approach. So instead of using this ratio, we can use this ratio as well. Okay, so we have this ratio and then we have this ratio. Now in this ratio, dA and dB means the same thing, which I already explained. Okay, distance to the conflict point for each vehicle. Okay, now what is this ratio? If you do distance upon speed, what do you get? Tell me. Distance upon speed gives you what? You know the equation of speed, right? So if I do distance upon speed, what do I get? Yeah, anyone? Distance upon speed gives you time. Okay, so this, yes, good. So the first equation was based upon distances. The second equation, the second ratio, is based upon time. How much time the vehicle requires. Okay, so and they have a factor of safety here as well. So we were taking dA up to what? Conflict point, right? And we are taking dB up to what? Conflict point. Okay, here they are saying the driver who is crossing. Okay, so and dB is for the driver who will stop. Okay, dA is for the driver who will cross, and dB is the driver who will stop because of the other driver. So they are saying that the driver who will stop should stop at least 12 feet before the conflict point, which makes sense, right? You don't want to stop exactly at the conflict point, you want to stop behind. And when you stop behind the conflict point, how much behind? At least 12 feet. The other driver who is supposed to move should have moved at least 18 feet in front of the conflict point. Okay, again, it's a good, it makes sense, right? Like, not the value, not the number 18, but it makes sense. The driver who will cross, he should cross before you reach your stopping point. Okay, so there's no danger. Okay, so they have put these numbers 12 and 18. These are empirical numbers. Okay, so they are saying the driver will cross the conflict point by at least 18 feet. So he will be in front of the conflict point by at least 18 feet. And this driver who will stop, he will stop behind at least 12 feet from the conflict point. Okay, so when they see each other, this driver will need or I'm talking about the crossing driver. The crossing driver needs this much time to go in front of the conflict point by 18 feet. This is his time to go in front of the conflict point by 18 feet from this position. Okay, and this one is the time this driver will need to reach his stopping point. His stopping point is 12 feet behind the conflict point. Okay, so this is the time required by driver B, and this is the time required by driver A. Okay, so when they see each other, one of them decides to cross, the other one decides to stop. The time in which he crosses is the same time in which he will come and stop. Okay, but so the time is equal. Time for driver A and time for driver B. Time for driver A to cross the conflict point and time for driver B to stop behind the conflict point. They are equal. Okay, but they are saying that they are not exactly calculated for the conflict point. They are calculated for stopping behind the conflict point and crossing the conflict point and going slightly ahead. Okay, so this time should be equal from the point when they see each other. Okay, so again this gives you the relationship or the equation between the available distances and the speed of the vehicles. Okay, and what is 1.47? The conversion factor. The speed will be in miles per hour. Okay, so this is just to convert the speed to feet per second. That's it. So this equation again gives you the ratio. Okay, so in this equation the dB value, who is stopping? The driver B, right? So the dB value coming from this equation should be at least equal to the side distance required by the driver. He wants to stop, right? This driver wants to stop. So the distance from here till this point should be at least equal to his required stopping distance. So you calculate dB from this equation, from this ratio. Okay, so the ratio is simplified as this much. Okay, and whatever you calculate should be at least equal to the stopping side distance. Okay, same thing here. You have this ratio. Okay, so from this ratio you can simplify it to this much. Whatever dB you calculate from here should be at least equal to the stopping distance required by this driver. Okay, so this ratio or this ratio, they give you the actual value of the available distance, and this actual value should be at least equal to the required side distance. Okay, two approaches. Any questions? Anyone has any questions? Okay, let us look at one example over here. So we have this road is one way, but this road is two way. Okay, so on this road I can have traffic from both sides. I'm talking about this driver now. Okay, this driver has to stop. Okay, so I will check if this driver has enough side distance or not. I will check it from both directions. Okay, I'll check it against this direction as well as this direction. Okay, what is my obstruction? The obstruction is there's a wall on the side of the road. Okay, on this side as well as this side, and the distance for the wall from the lane is given here. Okay, so distance to the obstructions are given from each lane. So if I'm talking about between for the right hand side, okay, then my A is 20, my B is 42 feet, right? Okay, the next thing I want to calculate is the required side distances. Okay, we have level terrain, that means zero gradient, and we have 2.5 seconds of reaction time, which is a standard value. I will calculate the required side distance for both these vehicles, and this will remain the same for vehicle C as well, because the speed and the terrain is same. Okay, so for the main road I will have one side distance, for the side road, crossing road, I have another side distance. So side distance for vehicle A or B, same, 1.47, 40.5, 40 square, okay. And for okay, let me, so we'll call it B or C, okay, because the vehicles are written as B or C here. So B or C, the vehicles on the main road. Then the vehicle on the side road, I'll call it A. Okay, so give me the side distances. Okay. And for the other one, with 30 miles per hour, how much? Okay. So who is supposed to stop? The vehicle on the side road, right? This guy is supposed to stop. Okay. So I will check if he has, if the actual distance is equal to his side distance or not. Okay, so I will use this equation. Okay. So now A is the distance to the roadside obstruction for this vehicle. Okay, for the main road vehicle. Okay, and B is from the other one. So A is this one now for me. Okay, and B is this one. So 42 and this one. So I'm changing the parameter according to what I have. So the other vehicle has 300.2. The distance to this thing, so dA will be the minus B, which is the distance for the other road, this one. Yeah. Okay, how much is that? So I'm calculating distance for the vehicle which was coming from the minor road because he has to stop, and I will check if it is equal to the distance which he requires or not. Okay, the distance is only 23.25 feet and he requires like more than 190 feet. So distance for the vehicle to stop from the to avoid the vehicle from the right hand side, conflict for the vehicle on the right hand side is not enough. Okay, this distance should have been at least 196.7. Okay, now if I check it for the other side, for this side, then I will use these distances 60 and 12, the distance to the obstruction on this side. Okay, so the left hand side, this one still has the same uh, stopping distance and 60. Minus 12. How much is that? Okay, so again we will check it with the required value, which is 196.7, and it is very low. It is more than what we have on the right hand side, but it is still very low as compared to his side distance. So when he looks at the vehicle on the left hand side or the right hand side and he wants to stop because the vehicles are very close or very fast, he does not have enough side distance to stop from this point. So whatever this point is, when he looks at the other vehicle here or here and he decides to stop, he cannot stop before reaching the conflict points. Okay, he will go and crash. Okay, now this is from this approach, this ratio. Okay, let us do these ratios as well. Okay, so we'll do the same thing. We have the speeds here. I'll put dA again for one side and the other side. It will remain the same, right? Because both sides have the same both sides have the same side distances. Both sides have the same dA. Okay, so it will remain the same. There is no A and B in this ratio, right? There is no distance to the roadside obstruction here. So if I use this ratio, I'm putting it dA because in the diagram this dA, because in the diagram it is vehicle A. Speed for the other vehicle, distance for one vehicle, this speed for the other vehicle, so 30. So how much is that? So much difference. Can you check it again? Which value is correct? Okay, so according to this ratio, he needs like 250 feet. Okay, so when we were using the side distance, he required how much? 196 feet, right? And if I take this approach, he needs 250 feet. Even if I take the number from Zenup, it is 183 feet, which is still less than the distance he has. So on one side he has 62 feet, the other side he has 23 feet. Okay, so whatever distance I take, 183 or 250, whichever value I take correct, the required the available distance is still more than what we require. Okay, I believe I was saying the other way around. I was saying we check it with the stopping side distance. No, this will give you the minimum required side distance. You check it with the distance you are getting with the ratio. Okay, so let me correct my mistake here. So if you want required side distance or required distance for DA or DB, one approach is using the side distance, the other approach is using this ratio. Okay, so the side distance gives you how much it should be required. Okay, and this ratio also gives you how much it should be, and then this ratio tells you how much it is actually. Okay, so the actual comes from here, and the required can be checked using the side distance or using this ratio. Okay, but in our case, whether we use the side distance, which was 196, or we use the timing approach, it gives us 250. The actual side distances are all less than these values, 23 and 62. Okay, now the next question is, your intersection does not have required side distance. What or the required distance to stop, side distance or the other one? What should I do? I have an intersection, and the intersection available distance is not equal to or is not more than what I actually require from any of the approaches. What should I do? What can I do at this intersection? It is not safe. The driver will try to stop and he cannot stop. What should you do? Yes, we can use signals, because signals then take out the issue of drivers judging and trying to cross. Okay, the other solution can be use stop sign on both the routes. So both drivers will have to stop when they are approaching the intersection. Okay, so this can be done as well depending upon traffic volume. Traffic volume is high, you go for traffic lights. If it is low, you may go for a stop sign on both the routes. Okay, so again going back to the concept of warrants, and as you already seen that there are intersections which may have yield sign or give way sign, and there could be a problem of stop, there could be a problem of side distance. And then there are other conditions in which a stop or yield sign can be used. So if a minor road is crossing a major road, then you can use a stop sign, provided that you already tried the give way sign and you saw that it's not working. Okay, or you are using it without any sign and you found that your experience shows that it's not working. Okay, and it can be used for an unsignalized intersection within a signalized area. So you have like an area where other intersections are already have a signal. There is another intersection which doesn't have a signal because we don't have enough volume or because of something else. So at least at this intersection you put a stop sign. Okay, so there are two conditions mentioned here. Okay, any of them exists, you will put a stop sign on the road. The first one is that you tried, there's a major road connecting with a minor road. Okay, and you tried it doing without the sign, any sign, and it did not work. You were seeing crashes or the traffic being blocked, so you will go for a stop sign. And the other condition is that around that intersection there are already intersections with signals, but you don't want to put a signal on this one, so you'll go for a stop sign here. The other conditions which are for two minor roads. So the first condition was for minor road crossing a major road. Okay, if you have two minor roads crossing, okay, then you will look at these conditions, the second set. So the first set is for major crossing a minor, and the second one is for two minor roads crossing. Okay, so these conditions, the first one is when the total volume is more than 2000 vehicles or units per day, and in these units they are adding the pedestrians as well. So if you have pedestrians plus vehicles from all direction more than 2000 per day, you should go for a stop sign, even if there are two minor roads. The second condition is for the side distance. The side distance is not enough, you should go for a stop sign. You have to stop the vehicle, right? The side distance is not enough, so they have to come and stop, and once they feel that they have enough, they should proceed. They have enough clearance from the other side, then they can proceed. So stop sign will make the driver stop on the intersection. So he will be near the stop line, and now he has a clear view of the other side. And the third condition is you have accident data. Okay, and the accident data shows that in the last 3 years you have two or more crashes of the vehicles which are crossing at the same time. Okay, so the crashes can be of different types, right? So you can have side crash, okay, side swipe, two vehicles which are in different lanes, and one of them tried to change the lane and he bumped into the other. This is side swipe. Or you can have rear end. One vehicle is going and the other one bumps you from the back. Okay, so this is rear end. This has nothing to do with the crossing traffic, right? This is happening in your own direction. Okay, so if you have crash of this type, then the stop sign will not do anything for them. But if you have crash or crashes which are from the crossing traffic, how many of them? Where is it? 5 or more in 3 years and 2 or more in 2 years. Okay, but which type of crashes? The one which are happening with the crossing traffic. Okay, so if you have crashes 5 or more in 3-year period of this type, then you can or you should go for a stop sign. Okay, so we had two sets of conditions. If you meet any of them, you will go for a stop sign. One is for major crossing a minor road, and the other set is for minor crossing minor. Okay, in the first case we are looking at that we already tried the yield sign, didn't work. You have a street which is a minor street entering a highway, and you have an unsignalized intersection within a signalized area. Okay, for the minor road we are depending upon volume. If there are two minor roads crossing, we are depending upon volume, side distance, and the crash record. Okay, for this one, okay, this is like a car is entering the main highway. Okay, so this is for crossing and this one is for entering. Okay, entering means he is turning right into the main highway. Okay, so the first one is like this. Okay, so car crossing from the minor road, and this one the car is entering. So this is the main highway, and then you have somebody entering. Okay, so the first one is for crossing, second one is for entering. So this is the difference between them. Okay, and so on and so forth. So these are the conditions at which you will go for a stop sign for at least one of the roads. And these are the conditions when you go for a stop sign for both the roads. We have four-way. Let me see. Yeah, always stop. So this is for a stop for only in one direction. So out of the 3 or 4 directions, only one will stop. This is for 2 directions. So out of the 3 or 4 directions, 2 will have the stop sign. Okay, and for them, and then we will have the always stop as well later on. So yeah, so first of all, a couple of notes here. The first note says that if you feel that stop sign is not required at all the timings, okay, so there is a particular time at which you feel the stop sign is required, then you can try first of all only putting the yield or the give way sign. Okay, so if you are thinking about putting a stop sign because of a specific timing of the road or specific timing of the day, then you can put a give way or yield sign instead of putting a stop sign. And in that particular timing, you can, like what we do here in Bahrain near schools, you have the security guards or the policemen, they just handle traffic for this 1 hour or something. So this can work instead of putting a stop sign for the whole day. Okay, so wherever you feel that stop sign is only required for a specific condition of the day, you can try keeping the give way sign there instead of the stop sign, and for that specific condition you can do something manually. Okay, manually. And then the second note is this one. So this is based on engineering judgment, and then you look at these conditions as well. Okay, so if any of the following conditions is met, you go for a stop sign. So the first one is, both of them are related to engineering judgment basically. The first two are, both of them, the first two notes are related to engineering judgment. First case, you judge that you have conditions which require stop sign for a specific time. The second one is that you judge that the stop sign is required for the whole day. Okay, and eventually the conditions which you can check against are these three. The first one is the vehicle traffic on the through road. Which one is the through road? The major road. Okay, so if the total volume on the major road for both directions is 6,000 vehicles per day or higher, then the minor road for both directions, the minor road both directions should have a stop sign. Okay, if the total volume of the major road is 6,000 vehicles per day or higher, then both directions the minor road should have a stop sign. Okay, the second condition is the side distance. If the side distance for the side street on both directions is less than the required, if the side distance is more than the available distance, okay, then both directions of the minor street should have a stop sign. And the last one is related to crashes. I already explained this, but now the numbers are changed. We are looking at how many? 5 or more crashes in a 2-year period. Okay, and again we are talking about crashes with the crossing traffic. Okay, yeah, so 3 or more crashes for 1-year period and 5 or more crashes for a 2-year period. Okay, then both sides of the minor street should have a stop sign. Okay, so you can use your engineering judgment, okay, to decide about it. And your engineering judgment, if it tells you that you only need it for a few hours, then you go for a give way sign, not a stop sign. Okay, and if your engineering judgment says that it's required for both directions for the whole day, then you should look into these conditions. If you fulfill any of these conditions, you will go with your judgment. Okay, and these conditions are related to the full traffic on the major road, 6,000 or more. Side distance for both direction of the minor road, and the crash record 5 or more in 2 years and 3 or more in 1 year period. If you exceed these values, you should go for a two-way stop sign on the minor road. And the crashes, as I mentioned earlier, should be those crashes which happened with the conflicting traffic, with the crossing traffic, not with your own side. Okay. Okay, so we are talking about side distances here. You already looked at this sort of a triangle, so we know what is DA and DB and everything. Okay, so this is if you are using the stop sign. Okay, if you are using the stop sign, then this equation gives you the driver who is the distance for the driver who is stopping. Okay, so this is the minor street, the driver is coming from here, and there is a stop sign for him. So he looks at the stop sign and he has to stop. Okay, and so he will when he will look at the stop sign, so stops, he will stop behind the stop line, right? He will stop behind the stop line. So how much behind the stop line? 18 feet behind the stop line. Okay, so DCL is from the curb line to the center of the closest lane. Okay, from the stop line, sorry, from the from the curb to the curb is the side of the road. Okay, curb is to the side of the road. Okay, and then we have 18 feet. They have given the description of the 18 feet as well. So the 18 feet is 8 feet, which is between the driver's eye to the front of the vehicle. So driver is here till the front is 8 feet. Okay, and then distance from the front of the vehicle to the curb line, this curb line. Okay, so he will basically stop before 10 feet before the curb line. Okay, so this is the 18 feet. Okay, and then we have the distance from the curb line to this. Okay, so this is your DCL. So this is DCL. Okay, this one is 10 feet, and then we have this one which is 8 feet. Okay, so they are saying this is the side distance he needs. He will look at the other car. Okay, and then he will stop this much distance before. Okay, so he will not stop here, or he will not stop at the conflict point. He will stop behind the stop line. How much behind? This much behind. Okay, so this is the distance at which he needs. Okay, this is the distance which he should have. Okay, so so at when he is trying to stop, this guy will not stop, right? This guy will not stop. He is on the major road. Okay, so at what distance he will cross? Okay, this is the distance for his crossing. Okay, distance for his crossing. S is his speed. 1.47 is the conversion factor. And what is TG? I mentioned in lecture 1 notes, there was something which we called as the gap. What was the definition of the gap? Anybody remembers? We calculated critical gap There was a question in the exam as well about gap. Calculate the critical gap. What is the gap? What is the meaning of gap? Distance between two vehicles only. Which distance? Which two vehicles? Distance between which two vehicles? You are right in this aspect. Yes, distance between two vehicles. Which two vehicles? Anyone has any idea? Yeah, but the passing and the next one from the crossing road. Okay, from the distance between, or the time between two vehicles which are crossing me. Okay, so when the first vehicle crosses from this side, I will make my move. So I'm stopping here. Okay, I'm standing here. This is my position. Okay, so let's say the first vehicle crossed me. Whatever the first vehicle one crossed this conflict point. Now I'm looking at the next vehicle. If I feel I have enough gap before the next vehicle arrives, I will try to cross, right? So this is this gap. Okay, when the first vehicle crosses this point, and the time interval for the next vehicle to arrive at this point, this is the gap. Okay, so how much distance this vehicle will cover during the gap? This much distance. Okay, so let's say the gap between the first vehicle and the second vehicle is 2 seconds. So this vehicle is 2 seconds behind. Okay, vehicle B is 2 seconds behind the conflict point. If the gap is 2 seconds, means after the first vehicle crossed me, the next one is coming after 2 seconds. So that means next one is how much far from the conflict point? This much far. Okay, so now I will decide, okay, whether I want to cross or not. So I'm standing here, I'm looking at the vehicles crossing this point. First vehicle crossed, the next one is coming after 1 second. Will I cross or not? I need to decide. Second one crossed, now the next one, according to my judgment, will come after 10 seconds. It is very far behind. Okay, so now I may decide to cross. So according to their studies, the acceptable gap for the vehicles on the stop line is 7.5 seconds. So if the next vehicle is supposed to arrive on the conflict point after at least 7.5 seconds, the vehicle which is standing on the stop line may decide to cross. Okay, it may decide to cross. So if the vehicle which is standing here has at least this much distance for the other vehicle to arrive, he will decide to cross. This is the minimum distance he will decide to cross, at which he will decide to cross, if the other vehicle is at this much distance behind the stop line. So we need to put in critical gap here, the acceptable gap, and according to their studies, the acceptable gap is 7.5 seconds. So this equation will give you the minimum distance required by this guy when he decides to cross. Okay, so you put the TG here. Okay, okay, and again, once you have calculated this distance, you will do what? You will go back to this ratio. Okay, and you will check if minimum dB is actually available or not. Okay, so now you have three criteria to check, okay, for the available distance. this ratio gives you the available distance. You can check it using the side distance, no stop sign, nothing. Okay, you can check it using this one. Again, it is also based on side distances, but based on the timing, and it has a safety factor of 18 feet and 12 feet as well. Okay, so available distance can be checked against the side distance. It can be checked against this empirical ratio with safety distances, or if you have a stop sign, then it can be checked against this this thing as well. Okay, so you have the available distance can be checked with these three criteria: the side distance only, the side distance with the safety distances 18 feet and 12 feet, or the distance which the driver has from the with the stop sign on the road. Okay, so dB minimum will be checked against what you get from this ratio, Okay, so this ratio is the mean which gives you the available distance. Once you have the available distance, you can decide, should I check it with only side distance or with side distance with additional distances. This is without the stop sign. If you have a stop sign, then you should check it against this one. Okay, and then dA comes from here. Okay, if you are using the stop sign, then dA will come from here. Okay, so you will use dA from here, take dB from the ratio actual, and then you will check if it is up to minimum or not. Okay, so dB is the through road. Okay, the road which doesn't have the stop sign. Okay, dA is for the road which has a stop sign. Okay, so if we have a stop sign, you can see here a two-way stop sign, both sides, this side as well as this side. Okay, all the lanes are 12 feet. So you have one lane here, one lane here, and we are the distance to the obstruction is given on the side. Okay, yeah, we will consider that it's to the center line. It doesn't show to the center line. We'll just assume it's to the center line. Okay, it will just not take much difference. So first of all, I will calculate the minimum distance required by these vehicles, vehicle B or C. The minimum distance will remain the same because we have level terrain same and we have the same speed, 40 miles per hour. Okay, so we'll check how much dB minimum we have. 1.47 40. I'm using the gap which is recommended by them. How much is that? Okay, so both vehicles need 441 feet. Okay, dB minimum for both sides, right hand side, left hand side, is 441 feet. Okay, now we need to check if we have enough or not. Okay, so first of all, I will calculate dA for both sides now. Okay, dA for the right hand side, left, and for the left hand side. Okay, so dA was distance from this lane, okay, the conflict point, to the curb line, then 18 feet behind the curb line. Okay, so from here to here, okay, the distance is, this lane is 12 feet, so from the center line 6 feet, this much is 6, then this much is 12. Okay, and then behind the curb line 18 feet more. Okay, so dA is for the right hand side 18 plus 12 plus 6. Which is 36 feet. Okay, and that one for the left hand side, okay, For this is my curb line, 18 feet behind the curb line, but the distance to the center of the lane is only 6 feet now. Okay, so 18 plus 6. Okay, so I have the dA for each side. Now I'll use the ratio dB. Let's say I'm doing it for the right hand side. So I need dA for the right hand side. Which is 36 feet. Let me look at the ratio. Where is it? This one, right? Yeah, so A into dA. Okay, A is the distance to the obstruction. Okay, obstruction is this thing. So distance, as I said, we are just assuming that it is from the center line. Okay, it doesn't look for the edge. Okay, so I will just take it 35 feet. Divide by what? dA minus B. Okay, dA is 36 minus B, which is the distance to the obstruction from the other side. So we are doing this one, right? Yeah. So 16 feet. Okay, this. And if I do it for the left hand side, my dA is 24. This is how much? Okay. The distance to the obstruction is 20. Let me just check something. A into dA. Okay, fine. Okay. My A is this one, right? Yeah, so I believe I made a mistake here as well. Obstruction, this one, yes, should be 16. Let me just check this. What did I do? Okay, so I need A and dA, which is for the other road, and dA minus B, which is for this road. So this is the other road. Okay, A is 35 and dA for this road. Sorry, this one is the other road, right? Okay, so dA was 36 feet and A is 16. Okay, that's fine. And then we have dA minus B. So dA is 36 minus B, which is the roadside obstruction for this one. Okay, and then we have dA into A, okay, minus upon dA minus B. I think so. Okay, so how much are these available distances? Okay, now you can see the for the right hand side, okay, the available distance is 576. Distance we need is 441. So we are good. For the left hand side we have a problem. Okay, the available distance is 216. The required distance is still 441. Okay, so dB left is less than dB minimum. Okay, so what can we do here? What are my options? One side has enough side distance. I'm using stop sign on both sides of the minor road, but for the major road, one side is dangerous. This guy, okay, this guy does not have enough distance, or if he tries to cross, this guy does not have enough chance to, look at him and then cross and so on and so forth. So basically, this guy and this guy, their crossing is dangerous. But for this side, it is good. We don't need to do anything. So what can we do? What is to be done? I already put stop sign on both sides of the minor road. Now what can I do for this situation? Even with the two stop sign, one side is still not safe. So what is your recommendation here? Yeah, everything. Yeah, everything is solved with traffic signal, right? Whatever problem you have in your life, just put traffic signal, right? So yes, we can do that. Okay, and we can use a stop sign on the major road as well. Okay, there is a chance you can use stop sign on the major road as well. But yes, a signal can be used as well. Okay, so this is the last one. Okay, always stop sign. So all roads, all sides have stop sign. Okay, so where can we use it? Some of the conditions. First condition is you are thinking about putting a signal in future. So you are designing the signal or doing some studies, or so in maybe few months I'm going to put a signal there. So using a always stop sign at this intersection is useful. It will make the drivers get used to stopping at the intersection from all sides. So they will not be coming at high speed. You have 5 or more crashes in 1 year period. Okay, and the crashes are for conflicting traffic. Okay, 5 or more only in 1 year. In the previous example, 5 or more in 2 years or 3 years, something like this. But if you have 5 or more with crossing traffic, then you should go for always stop sign. The third condition is related to volume. If the major street volume is at least 300 vehicles per hour for 8 hours of the day. Okay, major street volume from both directions is at least 300 vehicles per hour for 8 hours so for 8 hours of the day it does not go below 300. Okay, in 1 hour it is 300, another hour it's 400, another hour is 1000. So for a period of 8 hours it does not go below 300 for the major road. The combined volume for the minor road including vehicle pedestrian cycles, it does not go below 200 for the same 8 hours in which the major road volume does not go below 300. So let's say from 8 a.m. till 4 p.m. the major road volume total does not go below 300, and in the same time period 8 a.m. to 4 p.m. the minor total volume uh, including pedestrians and bicycles. So for the minor road we are including pedestrians and bicycles as well in the volume. So if this total does not go below 200 vehicles per hour. And the third condition is, so if you meet the first two conditions, okay, then you can go for, you know, go for a always stop sign. If you meet these two conditions, this one and this one, you can go for a always stop sign. If you don't meet these two conditions, then you look at the speed of the road. Speed of the road, 85th percentile speed of the road is more than 40 miles per hour. Then even if you reach to 70% of these values, you will go for our always stop sign. Okay, okay. Another thing was the minimum delay for the minor street is 30 seconds. Okay, in the peak hour. Okay, so these two conditions have volume and they have delay as well. Major road volume does not go below 300 vehicles per hour. Minor road, all volume including pedestrians and bicycles does not go below 200 for 8 hours. And the peak hour, the delay does not go below 30 seconds per vehicle. So if you meet these conditions full, you will go for a always stop sign. If the speed on the road is more than 40 miles per hour, on the main road is more than 40 miles per hour, and you meet 70% of these conditions, so you meet not 300 but 70% of 300, not 30 seconds but 70% of 30 seconds, and the speed is more than 40 miles per hour, then you will go for an always stop sign. Okay, and the fourth condition is you meet all these three conditions up to 80%. So this one and this one and this one, all these three are met to 80%. Okay, and this one also crashes. Okay, so if you meet these four conditions up to 80%, you will go for an always stop sign. Okay, so let me summarize. First condition is you are going to put a signal in future. You put always stop sign now. Second condition is you meet 5 or more crashes in 1 year. Third condition is related to volumes and delay. If you meet full volume and delay, these values, you will go for a always stop sign. Then there are exceptions. First exception is if the speed is more than 40 miles per hour. Then even if you meet 70% of the volume and delay, you will go for an always stop sign. Let's say the speed is also not a problem. Now you have met 80% of crash and volume and delay, all of them 80% at least, then you will go for always stop sign. So if you meet any of them, one condition, always stop sign. If you meet 80% of all of them, always stop sign. If the speed exceeds more than 40 miles per hour, only 70% of volume and delay is enough for always stop sign. Then there are engineering criteria which are mentioned here. The left turning is creating so much problem. Okay, you will see the traffic is getting blocked because of left turning. Too many pedestrian conflicts, pedestrian crashes. The side distance is not enough. Okay, and you have two collectors, okay, which are crossing the you have two collectors which are crossing each other in a residential area. Okay, so these are based on engineering judgment. Okay, you look at the road and you feel that if I put always stop sign, it will solve the problem. What types of problem they are mentioned here? Problem could be left turn blocking the road, pedestrians having problems, okay, problem of sight distance, but they are based on engineering judgment. Okay, so in all cases you have seen that engineering judgment has a part as well. Okay, I'll stop here. I think I already took extra time. Sorry for that.